This is the continuation of previous video. Storage unit, intermediate results and the final results. These are stored in the memory or storage unit before coming out into the output device. And the next thing is all input and outputs are transmitted through the main memory. For example, if you want to send input number 5 to print on the output, first it has to travel. I will show this in the block diagram of computer. If you want print a output number 5, for that you have to travel through this diagram. First you have to enter input number 5. It is taken into the control unit and given to the main memory, and their complex operations and functions are performed on that number, and it is written given to that main memory, and finally it come out of the output. Whereas this auxiliary storage is nothing but secondary storage devices or auxiliary storage devices. Okay, this is the schema to get an output from the feeding to feeding input. Okay, I think you get the point of memory unit a bit more better. Next one is control unit. It is responsible for controlling and transfer of data and instructions among other units of a computer. For example, if you want to retrieve a data, which means you want to get some data from your hard disk or anything, for that your control unit works to get the data. Your control unit activates hard disk in your computer to retrieve the data. Control unit is nothing but which controls all the actions which are held in the CPU. Every point in this control unit discuss that control unit controls all the coordinates and other components of the computer. There is not much important to discuss about this control unit, but it is important to know a little thing about this. Yeah, if you want to print an output, you have to communicate with that input and output device. For this, we use the control unit. It acts as the intermediate, like mediator. It works as mediator to communicate with input and output devices. It does not process or stores. As I said that it is intermediate or mediator. It acts as a mediator. So it does not process or stores any data. There is no need for this. And the third one in the central processing unit is the arithmetical and logical unit, which unit consists of two subsections, namely those are arithmetic section and logical section, or these are also called as arithmetical unit and logical unit. Functions of arithmetic section is to perform arithmetic operations like addition, subtraction, multiplication, and division. All complex operations are done by making a repetitive use of the above operations. There is no need, I think there is no need to explain this arithmetic section. You will understand by the definition of this arithmetic section. And the second one is logic section. Logic section function of logic section is to perform logic operations such as comparing, selecting, matching, and merging of data. This is also same as like arithmetic section, but here the logic section performs some of the operations to compare. Like for example, if I give a equal to 10 and b equal to 15, I want to compare that. If a greater than b, then print a is greater than b, or else if it is not satisfied, then I want to print that a is not greater than b. Here we give that b equal to 5. It means b is not less than a. So here we print that a is not greater than b. Section works. That's how logic section works. Okay. Next, the output unit. This is the final unit of the block diagram of the computer. Output unit is the nothing but monitor and printer. These are all output units which converts from the computer data to information. Output unit. The job of an output unit is it accepts the results produced by the computer in coded form. It converts these coded results to human readable form. Finally, it displays the converted results to the outside world with the help of output devices. Okay. For example, we gave that sum of two numbers. It processes of addition of two numbers and gives the output. How it gives mission readable language is converted into human readable language. For that, it converts the coded results to human readable form. For that, we use some devices. Those are output devices: monitors, printers, projectors. we can easily understand what the output is, which are in human readable language. We completed the second subtopic of introduction to computer, that is how a computer internally works with a rigid schema of block diagram of computer. And everyone should remember that block diagram of computer is nothing but a pictorial representation that how a computer works from feeding the data to giving the information. Okay, this shows the representation to get feed by data and to get give an output. Second topic of our introduction to C is types of computer. Types of computers: supercomputer, server computer, workstation computer, personal computer, microcontroller computer. These are the types of computers. I think there is no need explanation for these types of computer. Just read the definitions. Okay, it, for example, here supercomputer is nothing but it can do up to 10 trillion individual calculation per second. Server computer, for example, if you are browsing something in your Google or Mozilla, Firefox, anything, you will get regarding that. It means there is a server for that. Google finds what is the required output for your input. Those are the server computers. Workstation computers, it is high and expensive computer. This is made for complex procedures. Workstation computers mostly used in like IMD, Indian meteorological departments, weather departments, like these fields. These workstation computers are used. And personal computers are nothing but daily we are using laptops, PCs. These are all personal computers. And microcontroller computer is nothing but mini computer that enable that user to store data and execute simple commands and tasks. It has minimal memory. It is mainly used for embedded systems. Okay, these are the types of computers. Next topic is, this is the picture of types of computer. This is supercomputer, mainframe computers, microcomputers. These are PCs and microcomputers. And programming. This is our main topic. Programming. What is the need of programming? Why do we use programming? What is the need of programming? For example, if you want to communicate with a person, first you have to know what language the receiver can understand. For that purpose, here the computer also same receiver acts like that. For example, you are the client or you are the user of a computer. First, computer should understand what are you talking. So that's why program is introduced. Program is nothing but it is the intermediary thing to communicate with the computer. For example, if you want to add two numbers, how to tell that computer to add two numbers, but computer doesn't understand your language. It can understand only binary language.